Today, we're going to look at all the different ways we can write an equation for this particular sinusoidal graph. Let's remind ourselves of the things that we're looking for in the graph of a sine or cosine. So our generic graph looks like y equals a times the sine of b times x minus c plus d, or we're going to write y equals a times the cosine of b times x minus c plus d. So we got the x minus c in parentheses because I want the first thing to happen to the x to be subtracting c. Let's list what happens to the x in the order of operations. Let's read the expression and the order of operations, the things that happen to the x. Oh, not the order of operations, the order of operations. So if we're going to run an x through this function, the first thing that happens is we subtract c. And the second thing that happens is once we have x minus c, the next thing that happens is we multiply the result by b. The third thing that happens is we apply the trig function. That's where the sine or cosine happens. And then after we do the sine or cosine, we've got multiplication and addition. Order of operation says multiplication first, so then we multiply by a. And finally, we add d. So notice that we have a multiplication and addition before the trig function and after the trig function. The operations before are going to produce horizontal changes, and the operations after will be vertical changes. So the changes before are horizontal, and the operations after will be vertical. So we know that addition produces a shift and multiplication produces a squish or a stretch. So multiplication before is a horizontal stretch or compression, so that's going to change the period. Addition and subtraction before the trig function is going to be a horizontal shift. Multiplication after is going to adjust the amplitude, and addition after will adjust the vertical shift. So the numbers that we're looking for are a, this one just shows up as the amplitude. We also care about that, so that takes care of the multiplication after. Amplitude is a stretch, and it's a vertical stretch, so it shows up as multiplication for the stretch and after for the vertical. The other multiplication we have is b. This is where we're going to adjust the period. So where we see the period is 2 pi divided by b. So making b larger produces a compression, whereas making the amplitude a larger, the amplitude larger, produces a stretch. So one thing that we're going to notice is that the horizontal stuff seems to be inverted, because the way we want to think about it is that b is how fast we're going around the circle. So if b is 2, we're going around the circle twice as fast, and the period will be 2 pi over 2, or pi. So the period is 2 pi over b, and maybe more important for our purposes in this direction, b is going to be 2 pi divided by the period. C is addition before the function, so that's going to be a horizontal shift. And the way we wanted to think about this we wanted to think about C as the start. So whatever point we pick as the start, the x coordinate is going to give us the c. So c is going to be our start. Since the graph goes on forever in both directions, I put it in quotes. That's where I'm thinking of the middle of the graph, but the middle horizontally. So that's why I didn't call it the middle. And then the plus d is going to be where the middle is. One thing that we're going to notice as we go through more and more and more and more, more of these graphs is that the stuff that happens before seems to be inverted. If we add 2 before, it's going to shift everything to the left. And if we add 2 after, it's going to shift everything up. So plus 2 should make us think positive, and the positive horizontal direction is to the right. But if we add 2 before the trig function, it moves everything to the left. The way you could think about it is that 2 is the new 0. We got to think about what makes the x minus c equal to 0 for our start. All right. Let's talk about the starts, because we got to pick one place to start. Or maybe we'll do that third, because that's the order that I did things. Let's do that third. I was distracted by the shiny horizontal shift that we can find. Let's look at first the amplitude. The amplitude is just the distance from the middle to the top. So the distance from the middle to the top is the amplitude, or the distance from the middle to the bottom can be the amplitude as well. If these don't match, then we don't have symmetry about the middle, which means something is off. So for the amplitude, we're looking at how far things are apart in a vertical direction. So we care about the difference in the y coordinates. So at the top is at y equals 6. The middle is at 0, and the bottom is at -6. The amplitude is the distance from the middle to the top, so the amplitude is 6. And it's 6 in both directions. So we have an amplitude of 6. What that means for our equation is that A is equal to 6. Let's go for the other vertical stuff. The middle is where the y coordinate of all the points on the middle are. So the middle is once again a y coordinate thing. And notice that all the points labeled in the middle are at 0. So the middle is at 0, and the middle is just the value of d. So I've got the amplitude of 6, I've got a middle of 0, I've taken care of my 2 vertical things. Next, we need to look at try to figure out the period. The period is the length of one cycle between any 2 points that are at the same place on the graph. So that's going to be a horizontal thing. So that's going to be from a point at the bottom to another point at the bottom. So that's going to be 1 period. So in this case, the distance from the bottom point to another bottom point is going to be from -3 to 17. That's a distance of 20. So we can identify the period is 20. Notice that the period is the same from any 2 middle points going up. Remember, there's middle point going up, and then there's a mid going down. So if I go from a middle point going up to another middle point going up, I see that the distance between those 2 is also 20. Even though we don't see it, even though we don't see that I didn't label this point, we can imagine this graph continuing to go up and then drop it before dropping back down. And even though it wasn't given, if we go from -3 to 17 is a 20, from 2 to 22 is a 20. So from a 7, that'll tell us up here we should have a 27. And it should still be at the top, so that should still be at 6. So we can extrapolate from the data where the next point is going to be, or the next top point is going to be. And the distance between those has to be 1 period, which is still 20. For that point, we were using the period to find out where that point is going to be, but this all has to happen. We can also use this to go backwards, extrapolate backwards, and figure out where the middle that came before, the middle point going down is. So here's the point 12, 0 at a midpoint going down. And so the previous middle point going down should be 20 units before that. And the period always has to be 20. So if at this middle point going down, we're at 12, the middle point going down from before would have been at -8. And still 0. Because all the middle points have to have the same y coordinate. But now we can see the period of 20 in 4 different places. And we could use the period to extrapolate points before or after. "20 is not what we put into our equation, though. We have to put this number b into the equation. We know we calculate the period by taking 2 pi divided by b. So to calculate b in this case will be 2 pi divided by the period of 20. We could simplify this to be pi over 10. And we wouldn't have had to if we just started describing circles from the beginning with their radius rather than diameter. Diameter was more practical at the time. At the time we were describing, like I was there, at the time we were describing circles, it made more sense to describe them with the diameter than it did the radius. Then all this math came along, and then we looked back at the diameter and said, oh man, we should have used the radius the whole time. And then we were like, oh, well, it's too late to change now. And then thousands of years later, we realized it wasn't too late to change then, but it's definitely too late to change now. Maybe in 10,000 years, I'm glad we finally changed this. Who knows what's going to happen? So we're just trying to build all of the numbers that we're just going to stick into the equation. The amplitude is 6. The mid was 0, so d is equal to 0. And now we got the value of b, which is messy. It's pi over 10. We'll just write pi over 10. It's fine. The last one is the value of c that we're going to use. And that's going to determine whether we use positive sign, negative sign, positive cosine, negative cosine. So c will depend on where we choose to start. And there are 4 choices about where to start. We can start with a positive sign, where we start at the middle going up. We can have a negative sign, where we start at the mid going down. We can have positive cosine, which will be starting at the top, or a negative cosine, which means we start at the bottom. Those are our 4 choices. The c is going to be the x-coordinate at each of these points. So we can look at this graph as a positive cosine, a negative cosine. We can look at this graph as a positive cosine, a negative cosine, a positive sine, or a negative sine. Those are our choices. I'm going to start with a positive cosine. I'm just picking one. I have to pick one of the four. I choose positive cosine. I'm going to start, imagine that this graph starts at 7, 6, and I'm going to write an equation that starts at 7, 6. So I have to pick one. So I'm going to start at the top. And I pick a top point, 7, 6. C is going to, so since I'm starting at the top, that's telling me I'm going to write this as a positive cosine. So by choosing the top, I'm saying positive cosine. And I'm also saying that C is equal to 7. And I wrote the colors exactly backwards from what I wanted to do. It's not too late to change it, but I'm not going to change it. So I'm going to write my equation. I'm going to write y equals, it's going to be a positive cosine. Positive, we don't have to write the positive, but I'm emphasizing that. A is going to go in the middle, and I'm using cosine. A is 6, so I'm going to write positive 6, because A is the coefficient of the cosine. B is the coefficient of the stuff inside, so B goes in after the cosine parentheses, pi over 10 times x minus c, which is 7. Close the x minus c, close the cosine, and then plus d, which is 0. I wouldn't write plus 0 normally, but I'm emphasizing where things go. So here is one possible equation for this graph. We have an amplitude of 6. We're starting at the top because it's positive cosine. The period is 2 pi divided by pi over 10, which is 20. And the middle is at 0. And the C starts off at 7. That'll start at the top, which is a 6. Four other ways we could write this, which is actually an infinite number of ways we could write this. If we start at the bottom, that is, if I start at the bottom point, which is, I got a couple of choices here. So I'm going to use -3, -6. Since we're starting at the bottom, that means we're reading this as a negative cosine. And C is going to be the x coordinate of the starting point. So C is -3. That's the color coding I wanted in the previous one. So now when I write my function, instead of writing positive cosine, since I'm starting at the bottom, it's a negative cosine. The coefficient of the cosine is the amplitude, which is 6. Then in parentheses, I want a pi over 10 to tell me my period is 20. And then I'm going to write x minus c. And in this case, and I'm going to put the d on the outside plus 0, even though we normally wouldn't write that. And c is -3. So in the parentheses, it's going to look like x plus 3. The stuff before the trig function looks backwards. Multiplying by 2 compresses. Putting a -7 in, pi over 10, thank you. Putting a -7 puts the start 7 units to the right, which seems backwards. And putting a +3 in before the cosine means the start is -3 is 3 points to the left, even though it says +3. Some people see that as backwards. Don't see it as backwards. Just say, where's 0? Whatever makes x minus 7 0. So 0 is at 7. That's our new starting point. There's another choice that we could have made that was also starting off at the bottom. That was also a negative cosine. The other point that we had at the bottom was 17 -6. So we could say that the bottom is 17 -6, where we would have written y equals, it's still a bottom point, so it's still a negative cosine. A is still 6. B is still pi over 10. We have x minus c, and then on the outside will be plus d, which is still plus 0, which we still wouldn't be writing, yet here I am writing it 3 times. But in this case, c is 17, so x minus 17. So here are 2 representations of this function with 2 different starting values, either one at -3, -6, and the other one at 17, 6. Although both will produce the same graph, from a style perspective, we should choose the one that's closest to the origin. Just as a preference. It's not incorrect to use the +17 or the -17 one, but let's prefer the one closer to the origin. As far as the plus cosine goes, or as far as the negative cosine form goes. There's nothing wrong with it. It's just that there's a slightly better answer. Although points would never turn on that distinction. I would not be like all -10 points. You should have gone with the +3 rather than the -17. What's wrong with you? That'd be weird. Unless you're going to be writing code in the future, you should use like the -17, and then people will wonder why you picked that one. And then when they're like, "Oh, hey, computer programmer, why did you pick that one?" Just kind of shrug and said, "You wouldn't understand." And then they'll be like, "Oh, I understand code," and you'll be like, "Oh, no, you don't," because you're going to be writing code that's so inscrutable, no one can, unravel what you did. That way, you're the only one that can fix it. And that way, it's the way of job security. I don't know if that's true anymore. Like there are people out there that know how to fix Teslas now. So Tesla's like, oh, we have to make it not so. We have to find a way to keep people from doing that. You know what I mean? Anyway. So we can also choose points that are at the middle going up and the middle going down. But instead of writing plus cosine, we'd write plus sine or minus sine. So another function that we could use here, if we start at the point 2, 0, that's a point that's the middle going up. So it's a positive sign. And c will be the x-coordinate of the starting point. So the c is equal to 2. So I could write this equation, I could write an equation for this function by saying y equals 6 times the sine of pi over 10 times x minus 2 plus 0. And that would be thinking of this as the starting point. All of these equations will give you the same graph. So if we go to our graphing calculator, not our graphing calculator, our graphing calculator, and we put in y, and we put in the equation y equals 6 cosine. I want to click here. Y equals 6 cosine of pi over 10. This is the other thing I like about decimals. You just type pi. Pi over 10 times x minus 7 plus 0. We get the points that the same points that we have: negative 3, 6, 2, 0, 7, 6, 12, 0, negative 17, 6. Oh, dang it. I forgot that when you move it, it erases all your points that you labeled. So there's the point 22. I wanted to get this next point up there, 27, 6, so we can see. And we also get the negative 8, 0 that we found. Also, I can write this as y equals negative 6 cosine of pi over 10 times x plus 3 plus 0. Notice that the graph shows up on top of the previous graph. The other way we described it was y equals a positive 6 times the sine of pi over 10 times x minus 2 plus 0. Once again, now the green graph is just sitting on top of the previous two. And I could use the middle point going down, and I write y equals negative 6 sine of pi over 10 times x plus 8 plus 0. And now the purple graph is on top of the other three graphs because they're all the same graph. They all have the same points that we wanted before. Any questions? We're going to play this game a couple more times. One of the things that we need to look at, one of the things that's going to change is I'm going to change the middle to not be the x-axis. Notice that the x-intercepts are all easily identified points. But if I, let's see, turn these graphs off. If I look at a graph that has a different vertical shift, like plus 2. So notice that I've got I can easily call out my top and middle points, but I'm leaving you, my top and bottom points. The top is at 8 and the bottom is at negative 4. But the x-intercepts are no longer in the middle. So the distance between the x-intercepts is still going to be 20, but that's not where the middle is. 0 is not halfway between the 8 and the negative 4. But the x-intercepts will all be 20 units apart because I didn't change that. So if I gave you this graph, you would not want to look at 0 as the middle. The middle is at 2, and if I put that graph on there as well, then the intersections are at the 2, 12, the 22, 32, and the negative 8. That's where the middle is, because 2 is halfway between 8 and negative 4. So make sure you list your starting point correctly. I would not want to start this graph at 0.9180 because that's not at the middle going up. I'd actually be looking for the 0.22. And I might not tell you where these points are. I might not even sure. I'm not even going to draw that line. I'm just going to tell you where the bottom and the top and the bottom and the top are. And then you'll have to figure out where the middles are. There are two parts of figuring out where the middle is: the vertical parts between the 8 and the 4, and the horizontal part between the -3 and the 7. Any questions? All right, so I'm going to post up another graph. We'll do the same. We'll do the same format as last time. It's going to be a graded discussion. You just have to figure out the amplitude, the period, a middle. Those are all going to be the same for everybody. But then you'll also pick a starting value, and that'll determine your plus, minus, sine, or cosine. Write one of the equations. Or if you're feeling adventurous, write many equations. If you're feeling super pressed for time, just see what other people posted first. See if you could say, oh yeah, that's exactly what I was going to put. But make sure that you know where all those numbers came from. All right, that's going to do it for today. I will post up a new discussion for you to work on. I will see y'all on Wednesday, and thanks for playing.